So what we're going to do today is going to look very, very similar to what we've done in the past. It's way too much talking. So I'm going to draw something here, and you tell me. Let me just change the angle a little bit. All right. So what's this thing that I just drew right here? Is it? Mario, why'd you say quadrilateral? It's got four sides. Mario, is this a parallelogram? Why is it a parallelogram? Does it? How do you know? That's right. That's why I asked the question. You're absolutely right. So you figured it out yourself, right? So do you know for 100% that that's a parallelogram? No, you don't. Now, could it be a parallelogram? Absolutely. It sure looks like one, doesn't it? Okay? But we can't say that it is 100%. So what we're going to do today is this. If I give you some information, if I told you that this and this side were equal to each other, and I told you that this side and this side were equal to each other, now what do you think about this? Now it's a parallelogram. Because you remember, we used to say this. If it's a parallelogram, actually, I'll throw the word quadrilateral in there. We said if a quadrilateral is a parallelogram, all right, I'll just do the symbol for parallelogram, then what did we learn just the other day? Just, I don't know, what, 2 days ago, 3 days ago, something like that? If a quadrilateral is a parallelogram, then the opposite sides are what?
The same.
Yeah, let's say something better than the same. We could say congruent, or we could say equal. All right, congruent's perfectly fine. A lot of teachers would prefer that you say congruent, okay? I'm okay if you say equal. So this is the old stuff. This is what I said in the last class. This is the old thing we learned, like a lesson or two ago. I think it was maybe the last lesson. All right, we said if it was a quadrilateral. But remember, when I put it up there to begin with, did I know that it was a quadrilateral? Did I tell you it was a quadrilateral? Did I give you any information about it? No, I didn't. So we could not say it's a quadrilateral. But watch this. Instead of saying if it's a quadrilateral, then the opposite sides are equal, what did I give you? I gave you that the opposite sides were equal. So watch this. If a quadrilateral, has, how should I say this? Both pairs of opposite sides, both pairs of opposite sides equal to each other, then, now watch, this is the key to this whole lesson right here. So again, I did not tell you that was a parallelogram to begin with, did I? But you could see that it's a quadrilateral. And I gave you some information. I told you that these two sides were equal and these two opposite sides were equal right here, okay? So our theorem now says if a quadrilateral has both pairs of opposite sides equal to each other, then this thing is a what? Then it's a parallelogram. And I'll just do the little picture for parallelogram. You see the difference? Before, what did we say? I told you it was a parallelogram. Then you could tell me that the opposite sides were equal. Agreed? You could tell me some other stuff too. The opposite angles are equal, right? You could say that the opposite sides are parallel. You could tell me a bunch of stuff. There was stuff about diagonals. The diagonals bisect each other. There was quite a few things that we knew if it was a parallelogram. But now they're not telling you it's a parallelogram to begin with. They're just telling you, here's a four-sided figure, and I'm going to show you that the opposite sides are equal. If the opposite sides are equal, then what is this thing? Then it's a what? Parallelogram. But we didn't know that at the beginning, did we? But we had to know some information. So I'll call this ABCD. So if AB is equal to DC, and if AD is equal to BC, then this thing is a parallelogram. You with me? Okay, I'm going to go through the next ones a little quicker than I did here. I spent a little more time in the last class, so if you don't think that I gave you enough information here, go to the first class, because you guys got back late because of chapel, so I had more time in the last class. Now, Here we go again. I'm going to ask you the same thing. Is this thing a parallelogram just the way it sits right now? No. Well, actually, the correct answer would be we don't know. Very good. Okay, we just don't know. It could be, right? It has the shape of a parallelogram, right? But we just don't know it is. But what if I told you this? Now, this is kind of new. What if I told you that this side and this side are equal, and those same two sides, if they're parallel to each other, this is kind of new. This is now a parallelogram, and that's all I have to know. I don't have to know anything about that left side and that right side. All I got to know is what? Two things. I got to know that these two sides are equal, and the same two sides are what? Parallel. If I know that, then this thing is a what? Parallelogram. That's enough to tell me, okay? I'm not going to write it all down, again, just because of time. You okay with that? All right. So I'll tell you what, I'll just reuse this. If I can click this thing. Come on. Grab it. There it is. Okay, I'll put it right in the middle this time. All right, here's another thing. And let's go color. Let's add a little color to this. What if I told you that this... Now, again, do I know that this is a parallelogram? Get tired of asking this, but I got to ask it every time. Do I know that that's a parallelogram? No, I don't. I don't know if it is or not. Right? But what if I knew this? What if I knew that these two angles were equal, and I knew that these two angles were equal right here? Yes, because remember what we said? If the opposite angles are equal, then it's a parallelogram. Well, this is kind of like the flip version of it, right? If the opposite angles are equal, then it's a parallelogram. Before they said, if it's a parallelogram, then the opposite angles are equal. This one says, because I think I might have misspoke, this one says, if the opposite angles are equal, then it's a parallelogram. If you have one, that's not enough. You got to have both of them. Okay, it's a good question. Okay, if I only had this one and this one, that's not enough to make it a parallelogram. Okay, but if I have both pairs of opposite angles equal to each other, then it's a parallelogram. Let's do one more, and then we'll do an example. I can just undo those. Now what I'm going to do is draw a couple lines. You tell me what these lines are. What's that line considered to be? A diagonal. Very good. Right there. So I got two diagonals. Now, do I know that that's a parallelogram to begin with? No. Same question every time, okay? But watch this. What if they told us? Now, they haven't told me anything yet, but they are going to tell me some stuff. What if they tell me that this little segment from here to here is equal to that little segment? What if this one is equal to this one? So what did we just do right here? What did we do to the diagonals? We bisected them. Very good. Okay, we bisected the diagonals, didn't we? So guess what this thing is now? This thing is a what? It's a parallelogram. Well, it's not a review because what did we start with the other day? We started off knowing that it was a parallelogram. And then we said, oh, if it's a parallelogram, then the diagonals bisect each other. What's the difference today? It's a slight difference. It's a subtle difference, but it's a difference. What do we start with today? We just start off not knowing it's a parallelogram, but we do know that the diagonals do what? They bisect each other. So if the diagonals bisect each other, now what can we say about this four-sided figure? It's a parallelogram. You see the difference between what we did the other day and what we're doing today? Yeah. All right. Let's do a couple examples. And let's move that out of the way. Let's draw this. I'm going to make it look a little bit more like the book. Maybe like that. Yeah, that's good enough. Not exactly the way it looks, but it's good enough. And they actually turn it a little bit like this. Okay? Now, here's what they give you. They tell you that this side and this side are equal. Is that enough to say that that thing right there is a parallelogram? Just one set of sides equal? No. No, not just one set. All right? Watch this. They tell you this is 108 degrees, and they tell you this is 72 degrees. Now, you got to think a little bit, okay? They're not just telling you, I hate to give it away, but they're not telling you that this is parallel to this, but they tell you this is 108 and 72. What do we know about 108 and 72? That's 180, right? So that means these angles are supplementary. They're consecutive angles, aren't they? Right? So that means that what? If these are consecutive angles and they're supplementary, that must mean that this line is parallel to this line. Now look what we have. Now I have a quadrilateral with one set of sides equal and parallel. Do you remember that one? Okay, if I can scooch down. Oops. Oh, I erased it because I just backtracked on those. But anyway, if you look back on the video, right, you'll see that, right, that we had one of those. So is this now a parallelogram? Yes. And that's the question. So there might have a few questions. Is this a parallelogram? Don't just guess. Don't just say, oh, I don't know, I'm just going to guess. Yeah, it looks like one, I'll put yes, right? This is the reason. Because this one and this one are supplementary. They're consecutive interior angles, which means that these would have to be parallel. So if I got one set of sides that are both parallel and equal, then yes, it's a parallelogram. Make sense? Let's do another one. Then we're going to do one we'll do that. What is that thing? Very good. Tried to trick you a little bit, but you didn't fall for it. This is a quadrilateral. Okay, a lot of people would look at this and say it's a what? What do you think? Well, not a square. I don't think anybody say it's a square. It's a rectangle. It looks like a rectangle, doesn't it? But you don't know that. But watch what they do. What if they told you that angle and that angle were equal, and they told you this angle up here was equal to this angle up here? But these two are different, okay? This one right here is different than that one, but these two are the same. And these two are the same. Is this a parallelogram?
No.
Why not?
Well, yeah.
Because the opposite angles are the ones that have to be equal to each other. Okay, not the ones next to each other like here. Everybody see that? So are the opposite angles equal to each other? Question mark? No, they're not. So could we say that this is a parallelogram? No. Okay. We can't say that. All right, I only got 5 minutes. I was going to say something else about that. I do say something else about that and talk about a trapezoid. If you want to watch the other video, feel free. It's on there. All right, let's do this. And again, if I don't get to I want to do two examples here. I'll be able to get the first one done, but the second one, I don't know if I'm going to be able to get that one done or not. So I would go to the other class, look at their video. Oops, click off of that. There we go. All right, I'm going to draw a couple diagonals here and here. All right. Now, this is a little different. We're not just saying, is this thing a parallelogram or not? They're going to give you some values, but they're going to put some variables in here. Remember we talked about the substitution stuff? Okay, this is where you're going to use it. 6b plus 2, and this is 7b minus 4. All right, this is 5a, that's 20, 7b minus 4, and 6b plus 2. Actually, this is not the substitution one. The next one is the substitution one. But let's do this really quick. The question says, find the value for each variable. So I'm solving for a and b. That's my answer. A equals something, b equals something. I'm solving for a and b. Okay, that ensures that this whole quadrilateral is going to be a parallelogram. Like, what does that mean? Well, I got diagonals, right? So if I can show that the diagonals bisect each other, then what is that quadrilateral? It's a what? It's a parallelogram, isn't it? So how in the world do I show that these diagonals bisect each other? Well, if I can show that this little part and this little part are equal, then that's being bisected, correct? If I can show that this one and this one are equal to each other, then it's being bisected. So that's what I'm going to do. Okay, I want to try to show, I want to set these equal to each other. So I'm going to go 5a equals 20. Divide by 5, a is 4. Okay, right here, set those equal to each other. I'll go 7b minus 4 equals 6b plus 2. Let's solve for b. Subtract 6b from both sides. Add a 4 to both sides. What's b? 7b minus 6b is b. 1b equals 6. Good. And that's your a and b. So if a is equal to 4 and b is equal to 6, then this thing is a parallelogram. Good. I think we're catching on, aren't we? Do we have time to do another one? Yep, let's do it. Again, I take a little bit more time in the other class because I had more time, so if you want to go back and look at that, feel free. Okay. Let's write some stuff in here. This is the substitution one. So this is x plus 11. This one is y. This one is 2x. And this one is y plus 14. 14. Okay? That's a 4. It's an ugly 4. Check it out. What must be true in order for this to be a parallelogram? The opposite sides must be what? Congruent or equal to each other. That's right. Okay, these two sides must be equal, and guess what? These two sides must be equal. Let's write it. I'll put it right in this picture right here. So let's set these two equal first. All right. Since y is by itself, let's put that first. So y equals x plus 11. If that's the only thing I knew, could I solve for x and y here? No, because I don't know what x is, right? If I knew what x is, I could find y, but I don't know what x is. I need another equation. Where am I going to get that from? Right here. What's this? Y plus 14 equals what? 2x. Now watch what I can do. Watch very carefully. This is something you're going to have to do tomorrow on the quiz. It's not going to be the same exact problem. All right? But this is a substitution. So if I have these two, what am I going to do? Y equals x plus 11. So I'm going to take that x plus 11. Where am I going to put that? In for that y right there. Everybody see that? Okay, that's what y is equal to, and there's a y right there, so let's put it here. So instead of y plus 14, what am I going to have? X plus 11 plus 14. Very good. See, that substitution is not hard, is it? All right. So this is going to be x plus, actually, let's do this. Let's get rid of the x, because I get x on both sides. So let's subtract an x. And what is this going to be? It's going to be 25. That's going to cancel. What's this going to be? X. So x is what? 25. Okay. How would I solve for y? Well, remember, y equals x plus 11, doesn't it? So y equals x. What did I say x was? 25 plus 11. And what's that? 36. And that's your answer. So if y is equal to 36, and if x was equal to 25, then this would be a parallelogram. All right? So this is the substitution, the stuff that we did right here. Okay? That's the substitution. You will have at least one. I think there might be 2 problems on the quiz tomorrow where you're going to have to do some substitution. But it'll be very, very similar to the substitution that we did right here. Okay? Make sure you study it. Watch that other lesson where I did some substitution as well. All right? That could be helpful. So be ready for the quiz tomorrow. It's going to be pretty much the same stuff. So go over the quiz that you took, right? If you know how to do the problems on that quiz.
So what number would that be?
It's one of the last ones. I can't remember.
So everything won't be the same, different number?
Kind of the same. It's going to be kind of the same. It's not going to be exactly the same. No, you'll see. You'll look at it and you'll compare them. Actually, one of the problems is exactly the same. You hear me? Zion, you're not even listening to me. Zion, look at me. Look at me. I'm talking to you. One of the problems is going to be exactly the same as the one on the quiz. I'm not going to tell you which one, but one of them is going to be exactly.
He said because he felt like it was too easy. The one that we took was too easy.